So we left off on normality. So we ended it with ideal gases and molarity. So another sort of terminology you need to be familiar with is normality. And normality of solutions is the product of the molarity times the number of valence charges taking place in a reaction. So this is the definition you see in your reference handbook. But when you expand it out into formulas, you have a normality of an acid and a normality of a base. So you're taking the molarity, depending on if it's an acid or base, and you're multiplying it by the number of H plus ions or the number of OH minus ions. So if you're dealing with a base, you're dealing with hydroxide ions. If you have an acid, you're dealing with H plus ions. So using those formulas, you can solve all of the problems you need on the FE exam, but I've included this slide just in case they ask you about something called equivalence. And equivalents are tied into normality. So an equivalent of an acid is the amount of an acid that contains 1 mole of H plus ions. The equivalent of a base is the amount of base that contains 1 mole of hydroxide ions. So this is something they most likely won't ask you. They'll probably just ask you to solve for normality. But just in case, if they ask you about equivalence, here are the formulas for an equivalent. This is not in your reference handbook. This is something you would know just by solving problems. So 1 gram equivalent of an acid is equal to that molar mass of an acid over the number of H plus ions in that formula compound, formula unit. 1 gram equivalent of base is the same formula, except you're dealing with hydroxide ions. So when you calculate these gram equivalents, you can plug that into this formula in the numerator and divide by the liters of solution. So this is another way to calculate normality, and we're going to go through a problem where normality is solved for using both equations. So here is a example I want to go through. So let's say you have hydrochloric acid. When I say it's a monoprotic acid, what does that mean? Can anyone tell me what a monoprotic indicates? Yeah, so the literal definition is 1 proton, but what they're trying to say here is monoprotic, 1 proton, 1 positive ion. So 1 positive H plus ion if you're dealing with an acid. So HCl is comprised of 1 positive H plus ion. So if I wanted to find excuse me, the gram equivalent of HCl, I would take the molecular weight, which is this formula here, molar mass or molecular weight of HCl, and divide it by the number of H plus ions in that acid. So if you look up on the periodic table, the molar mass of HCl is 36.5 grams, and that's divided by 1 H plus ion, because there's only 1 H plus ion in this compound. So the 1 gram equivalent of HCl is equal to 36.5 grams, which is the same as your molecular weight. Now, what if I had an acid that had multiple H plus ions? So sulfuric acid, which is H2SO4, is a diprotic acid. Diprotic meaning 2 protons, so 2 H plus ions. The molecular weight of H2SO4 is 98 grams. So if I take that 98 grams and divide it by 2H plus, because I have 2H plus ions, I'm going to get 49 grams. So the 1 gram equivalent for sulfuric acid is 49 grams. So it's not always equal to the molecular weight. Everyone understand that? So that's how you find gram equivalents. Now, this is, if they give you this question, It's a rare question if they ask you to find equivalence, gram equivalence. But I want you to have this slide just in case they do